Okay, in this video we're going to talk about simplifying radicals, or specifically simplifying square roots. But again, remember I said radicals is that generic term for any root that we're taking. So in the past two videos we talked about simplifying perfect squares. So taking the square root of perfect squares. Now, in a perfect world, every number would be a perfect square and you could take the square root of it and everybody be hunky-dory and everybody be fine. However, this is not a perfect world and we have a lot of numbers that are not perfect squares. Because honestly, look at this table. You go from 1 to 4. What about 2? What about 3? Or 4 to 9? What about 5, 6, and 7? So there's a lot of numbers that are not covered on this table. So we're going to talk about, well, what happens when we get one of those numbers and how do we simplify it. So the first one we're going to talk about is, we're just going to do tons of examples on these. So the first example is square root of 12. Okay? Well, first of all, I'm going to ask myself, is there a number times itself that equals 12? Not that I can think of. 3 times 3 is 9, 4 times 4 is 16. We have skipped over 12. Okay. Well, then I'm going to think about, okay, well, is there a perfect square number that goes into 12? So I'm going to look at this blue column, okay? And I'm going to think, okay, is there a number in this column that 12 can divide by, or a number in this column that can multiply by something to equal 12? Well, 1 times 12, but if I take the square root of 1, I get 1, and that's not going to take me anywhere, so we're just going to kind of skip 1. But what about 4? Well, 4 times 3. 4 is a perfect square. Okay, we're on to something here. So now I'm going to take this and I'm going to write it as the square root of 4 times 3. Okay, so I just broke up 12 into 4 times 3. Now I can break this up further and I can say the square root of 4 times the square root of 3. So there's a rule or a property that says that if I am taking the square root, or if I'm taking the same root of numbers, I can multiply them together underneath that root. So I have the square root of 4 times the square root of 3, so I can break this up into 2 separate square roots based on that rule. And we'll go into that more in a different video. But now I have the square root of 4 times the square root of 3. All right, well, square root of 4, I can simplify that further because the square root of 4 equals 2. Now, square root of 3, I can't do anything with. There's no perfect squares that go into it. It's just going to stay the square root of 3. So my final answer is 2 times the square root of 3. Now we can go check that too. So let's see. We had square root of 12. All right, that gives me 3.46, blah, blah, blah. And then our answer was 2 times the square root of 3. So basically what I'm going to do here is I'm going to make sure that 2 times the square root of 3 gives me the same answer as square root of 12. So we have 2 square root 3, and indeed we do get the same answer, 3.4641 onwards. So we did simplify this correctly. So we can always check to make sure we simplified it correctly by just plugging it back into our calculator and making sure they give us the same big long decimal. Okay? All right, let's try another example. Let's try the square root of 18. So 18 is not in my list, but there is a number on my list, 9, that can multiply by something to equal 18. So I'm going to have the square root of 9 times 2, square root of 9 times the square root of 2, again just breaking it up, not a big deal. Square root of 9 is 3, square root of 2 I can't do anything with, so we get 3 square root 2, and if you wanted to, you could go to your calculator and check to make sure that the square root of 18 is the same thing as 3 times the square root of 2. So now let's try the square root of 48. So sometimes numbers have more than one perfect square that goes into it. The first two examples we did, they didn't have more than one perfect square. But 48 does, okay? So first what I'm going to do is I'm going to say, okay, well, what is the biggest number on this list that goes into 48? Well, that would be 16, okay? So I'm going to break this up into the square root of 16. 48 divided by 16 is 3, so it's 16 times 3. Square root of 16 is 4. Again, square root of 3 we can't do anything with. All right, so that is the quickest way from your unsimplified radical to your simplified answer. However, say you didn't realize that 16 was the biggest one that went into it, and you picked 4. So we have square root of 4 times the square root of 12, because 4 times 12 is 48. Square root of 4 is 2, and then we have square root of 12. So as we reach these answers, we have to ask ourselves, is what is underneath that radical, or the square root symbol, is that completely simplified? Or is there a perfect square that goes into it? Well, at the beginning of this video, we did the square root of 12. And we know that that can be simplified. So we'd have 2 times the square root of 4 times the square root of 3. I'm just breaking up my square root 12. Then I would have 2 times 2 square root 3. And again, this 2, I'm just pulling down from before. Okay, and then square root of 4 became 2. So now we have 2 times 2, which is 4, times the square root of 3. It's 4 square root 3. So I could go either way. We get the same answer. If I recognize 16 was the biggest one, cool. If I didn't, it doesn't matter. Just keep simplifying until you get all the way down to a completely simplified answer. 3, we can't do anything with. There is no number on here other than 1, which again, 1's not going to get us anywhere, that goes into 3. Okay, so in the next video, we're going to work on a lot more examples like this.